ambient circuit alloy is a toroid. Torroid is also used for many purposes, right? Torroid is a solenoid only. A long solenoid is bent in the form of a circle, right? You see it. When current flows through this number of turns, this is also just like solenoid only, insulated copper wire, but that is bent in the form of a circle. Sometimes it is called as endless solenoid, right? When current flows through this, magnetic field lines are produced inside. That is set up inside. So many lines of force are there. This 1, 2, 3, etc. We can fix one of the magnetic lines of force as a closed path, because we now wish to calculate the intensity of magnetic field inside a toroid using ambient circuit law. For using ambient circuit law, what do we need? We need a closed magnetic path. This is the closed magnetic path, which is the distance r away from the center, right? So along this magnetic path, if you take a small length dl here, at this point P, suppose this point is P, if you take a small length dl at this point, and a tangent is placed at this point, that tangent with the arrow head shows the magnetic intensity direction. And also at this point, when you place a tangent like this, the tangent and vector dl makes an angle 0. That is theta is equal to 0. So now let us see then how we can calculate the intensity of magnetic field inside the toroid. So toroid description is over. This is only a solenoid only. Solenoid is turned round in the form of a circle. When current flows through this, magnetic field is produced or set up inside it. Now let us see how the derivation can be obtained. Magnetic lines of force is shown by the dot mark. See, that means inside the solenoid circle is the middle circle that you can refer is the closed magnetic path. We can apply ambient circuit law in this case also. The line into the magnetic field over the closed path, integral B dot dl over the closed path is equal to integral B dl cos 0. Why 0 I said? Because vector dl, that means vector dl is a small line at the point P where I mentioned, and the direction of B makes an angle 0, theta is equal to 0. Therefore this is equal to closed integral B dl, because cos 0 is equal to 1. That is equal to B into integral dl. So dl is small part of a circle of radius r. Therefore integral dl is equal to 2 pi r. This turns as equation number 1. Now, what by ACL? ACL means ambient circuit law. Line into the magnetic field over the closed path is equal to mu 0 into current enclosed by the path. How much current it is enclosing? Right? The total path has a length is equal to 2 pi r. This toroid has unit length of the toroid has n number of turns. Hence, 2 pi r length or circumference of the magnetic path has how many turns? 2 pi r into n, or n into 2 pi r. Every turn carries a current I. Therefore, the amount of current enclosed by the path, the circular magnetic path is equal to n into 2 pi r into I. From 1 and 2 we can write B into 2 pi r, because this is also B dot dl, this is also B dot dl. Left hand sides are same, therefore right hand side also must be same. That is D into 2 pi r is equal to mu 0 n into 2 pi r into I. This 2 pi r cancels. We get B is equal to mu 0 n I for air or vacuum. If the medium inside the toroid is replaced by another medium of high value of relative permeability mu r, then B is equal to mu 0 mu r n into I, where mu r is the relative permeability of the medium introduced inside the toroid. That is equal to mu into n. Again, you know that mu is equal to mu is the absolute permeability. You know that mu r is equal to mu by mu 0. Therefore, mu 0 mu r is equal to mu ni, and this is about toroid. These are the applications of Ampere's circuit law. This topic is also finished.